Hi everyone and welcome to the second part of my reaction to quantum mechanics is wrong, and anyone can exactly see why. Yeah, we left off last time at him saying that quantum mechanics is weird and counterintuitive because it's wrong, which, you know, is a bold statement to make. Let's see what they have in store for us.
And when I say wrong, I mean there are mathematical mistakes and logical contradictions or paradoxes that are built into the foundation of this physics.
Just at our university alone, there are about, I'd say 100, maybe 150 if you count in the guys from astronomy and related fields. About 150 students every year to take the intro to quantum mechanics. So are all of them wrong? Do none of them notice all of the obviously so apparent mistakes? Or maybe, just maybe, is it that you're wrong? I find this behavior in flat earthers a lot, where they say, I don't know if you're a flat earther, where they say that no, and it's so obvious, and I love them saying that it's so obvious. If it was that obvious, why has no one from the field noticed it yet? It bears no logic. If you find a mistake today in the more basic section of quantum mechanics, wow, you have your work cut out for you. You don't have to apply to anything ever again because they are going to call you about stuff.
And the failure to build a quantum computer will help.
A quantum computer is a thing that exists. You please tell me you know that. There are even people at our university that during the introductory lecture to quantum information are allowed to submit very, very primitive calculations to a quantum computer. It's more like a gimmick so that you can say that you have calculated stuff on a quantum computer, but it's still a cool thing. I didn't take the lectures in quantum information because I don't think I would be very good at it, and I don't think it's very interesting for me. But I know people that have, and they told me that they have been using a quantum computer. So that's interesting. How old is this video? It's from 2 years ago. Okay, well, that's wrong.
Prove this. Yes, they are fake, and the reason is because quantum state superposition is not.
It's fake. Okay, I understand. That's the good old flat Earth argument of it's fake, no evidence provided, and they are even doing the same thing with look how much money is in it. Like, don't get me wrong, I'm very critical of everything involving money, right? But just something involving money doesn't mean it's fake. My example from previously, anesthesiology also involves a lot of money, and yet it's real. If you don't think it's real, you could do your next surgery without any anesthesia.
Not real. Quantum state superposition is the Achilles heel for quantum computers.
I mean, it's certainly difficult to maintain, especially in the environments that they are in, but it's certainly not impossible.
If this doesn't work,
and if quantum state superposition is not real, I have a couple of very interesting experiments for you.
then quantum computers will fail. So this statement right here is pretty much the punchline on why quantum mechanics is wrong and why quantum computers will never work. And finally, this will serve as an example of why you can't just believe in science or scientists. You should be able to increase your own understanding enough to where you can question paradoxical or logically contradicted statements, such as,
yes, I very much agree. You should always read up on stuff that anyone tells you. That is completely correct. Making me think that you haven't.
wave-particle duality, and complex math can be quite intimidating. But just realize that math is a way of describing a concept, or a set of concepts.
Well, it's a way of describing reality, really. Don't need to bring any concept in here, but yeah, sure.
That you can understand. So let's focus on the photon light particle.
Okay.
This is absolutely the biggest problem with quantum mechanics.
I'm very curious what happens next.
The simple question that you can ask any physicist is, what is the definition of a single photon particle?
The definition of a single photon particle would be, at least for me, the photon is a fundamental particle. Wait, hang on. Let's get to. So my exact answer would. Oops, sorry, I meant to click the whole thing. Yes, exactly. So what I was about to say is that the photon that can be seen right here is one of the fundamental building blocks of the universe. It is part of the standard model. It is a gauge boson. That means that it carries one of the fundamental forces, or at least interacts with them in some sort. Photon is right here, and as you can see here, it has a mass of 0, a charge of 0, and a spin of 1. And mass, charge, and spin are, without any prior explanation, I mean, mass and charge are usually somewhat easy to explain. Spin is a bit more difficult. But it is just what we have found, that there are kind of just 3 fundamental properties of anything, and it's mass, charge, and spin. And the photon has 0, 0, 1, like, you know, it just has that. We can measure this. And you could go further and say, well, the photon is an electromagnetic wave, as well as a particle, because waves and particles can be the same, so on and so forth. That's, I mean, I'm doing this more or less blind as usual, so,
It sounds easy enough to answer that, but I'm telling you, there is no answer because of
I disagree.
this. The standard definition
Oh god, what
for a
happens now?
photon is based upon its energy, or E.
I mean, no. I mean, it certainly is one of the more fundamental properties of light, that the energy is Planck's constant times its frequency. But I mean, I wouldn't say that is its definition. I guess you could make up a definition from this energy, but I think it is more important to say that it's massless, chargeless with spin 1. You can, of course, add all of its properties on it, but,
E in this equation. And the photon's energy is proportional to its frequency, or F in this equation.
That is correct, yes.
And the kicker here is that this equation is a wave equation. It describes the behavior of waves and not a particle. So this is where wave-particle...
I mean, just because there's frequency in it doesn't mean that it's a wave equation, right? If you want to see a wave equation, for example, in Wikipedia once again, again, not to be confused with wave function, the fundamental property of any wave, or at least for a scalar wave, is this one right here. So, could you tell me please, does this look a lot like this? I don't think it does. There can be the Lambert operator, which, that is what we learn in electrodynamics of how this whole thing looks, is that light fulfills this equation here in vacuum, of course. Yeah, so you can have different equations for water, for things like that. So, but that is a wave equation. That's just a linear formula.
Duality comes from. We're thinking about particles, but the math is using wave equations. Now let me show you how to illustrate this using a 3 Hertz frequency.
Again, this is not a wave equation.
Example. Anyone can draw a visual representation.
So, could you tell me where in this HF there is a cosine? Because H is a constant of nature, so there's no cosine in there. To be fair, this is a sine, but I was looking at the general form. And f is a frequency. 3 hertz isn't a wave. 3 hertz is 3 hertz. There is no wave into it. Now, of course, you could say 3 hertz describes a wave, in which case I am all there with you. But the plot here has nothing to do with E equals HF.
Of this wave equation. You can see we have 0 to 1 second represented on the x-axis.
Mm-hmm.
Instead of looking at this as a mathematical sinusoidal waveform, we can easily visualize it as waves of water. The x-axis would represent the surface of the water if it was calm and there were no waves.
To be fair, water waves are by far not as fundamental as light waves. Water waves are actually surprisingly difficult. They told us in university that if you have to explain light and electromagnetic waves to someone, you should maybe not use water waves, because water waves are not archetypal waves in a physical sense, which makes it a bit annoying to handle.
You can see the 3 wave peaks that happen within the 1 second period of time. So water is the medium that has been disturbed, and the effect of that disturbance are these waves. So now we have a frequency of 3 waves in 1 second of time. In other words, 3 hertz. Now the 3 hertz frequency needs to be multiplied by this letter h. So let's put an h by each one of these wave fronts. So each one of these h's represents the energy of each one of these waves. To follow on with our water analogy, I put them by the wave front because when we get hit by waves of water, we can feel the energy of the wave itself.
Now with water, that's a bit more difficult because, and I can be wrong here, if I remember correctly, I think water waves are very weird about actually carrying the energy. Sorry about that crack, by the way. That was my desk. It's very weird. If I recall correctly, water waves don't just carry energy like it is depicted here. It's complicated with the currents and stuff.
If you're to think of this as a particle of light or photon, you would somehow have to stretch this photon to be 1 second long.
Whoa. What?
You would somehow have to stretch this photon to be 1 second long.
No, not at all. You don't. No. That is not what's going on here. What you... I can see where the confusion comes now. Hertz is defined as vibrations, or, well, I guess, yeah, let's call it vibrations. Vibrations per second, so like amplitudes, if you would. Technically, hertz is 1 over second, right? So, exactly. Is frequency. It's event per second. Cycle, that's what I was thinking of. I was thinking of cycle per second. So events per second. That's what hertz is. And I can, okay, I see where the confusion is coming from. 3 hertz does mean that something occurs 3 times every second, but that does not mean that you need to observe it over a whole second. If this was the case, there would be no possible communication that lasts shorter than a second, because communication happens with photons. That's such a flat earth way to think about things. By now I would be pretty surprised if this person isn't a flat earther, because that's the logic. Like I would hear something like that from Flatzoid. That is very flat to me.
In order to encapsulate the energy of this wave equation.
No. A photon that has 3 hertz. 3 hertz is really little. Let's say 3 gigahertz. That's more of a reasonable thing. That just means that the amplitudes here are squashed together. Very close. That's all that it needs. You don't need to wait for it for a whole second. You just need to look at the frequency at which the electric and the magnetic field that I showed you earlier are actually oscillating or cycling, if you will.
So do you really think that photon particles are 1 second long? Because 1 second...
You apparently think that, and that completely throws me away. How would information technology be possible? Nothing should be possible that happens on any sort of modern computer, because like my processor has probably 3 point something gigahertz, right? Speculation, I think. 3 point something gigahertz. So how can it do things quicker than 1 second? Obviously it can't, because it needs to wait a second for it to finish the process.
at the speed of light
That's
is
a good one.
300 million meters, which is basically from here to the moon. If scientists use this equation to define a single photon, then I hope
Good thing that we don't.
you can see that they've gone off the deep end. And I hope you can see how you can easily debunk this idea.
Yeah, no, but that is not what's happening. That is just not what's happening. That is such a wild misunderstanding of, first of all, units. Hilariously fun. By the same logic, I could not weigh the pen that I'm holding right now, because I'm always fiddling around with something. The pen I'm holding right now, I could not weigh, because, well, weight is defined as kilograms, but my pen has a couple of grams, so I couldn't weigh that. Oh, that's a bummer.
And there's no question that this is an embarrassingly simple mistake.
Okay, I wasn't prepared for that. Very, 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 very funny, and not really not what I was expecting from this video, but hilarious nonetheless. Now, it is already 17 minutes in, so I think I will leave it at that. I thank you very much for watching. If you enjoyed this video, maybe consider liking. If you enjoyed it a lot, maybe considering subscribing. And with that, I will see you in the next video. Have a fun time until then, and goodbye. Good.